In 387 BCE, outside the city of Athens, the Academy of Plato was officially founded. At its entrance stood a sign which read, "Let none ignorant of geometry enter here." The Academy trained numerous mathematicians. Plato's own contributions to mathematics primarily involved documenting and explaining the 5 regular polyhedra: the tetrahedron, cube, octahedron, dodecahedron, and icosahedron. In this video, we will explore 3 questions. What is a regular polyhedron? Why are there only 5 regular polyhedra? And the reasoning behind Plato's association of these polyhedra with elements. What is a regular polyhedron? To classify a polyhedron as regular, it must meet 4 conditions. First, each face of a regular polyhedron must be a regular polygon. This octahedron, after deformation, no longer has equilateral triangular faces, so it is no longer a regular polyhedron. Each face of a regular polyhedron must be identical. This polyhedron is quite common. In recent years, a popular new material, carbon-60 fullerene, has a molecular structure like this. Carbon-60 is also called buckyball, as its shape resembles a soccer ball. Each face of this polyhedron is a regular polygon, but not all faces are identical. Some are pentagons, while others are hexagons. Therefore, this polyhedron is not a regular polyhedron. Each vertex must connect the same number of edges. The first 2 conditions are fairly intuitive, but this one is often overlooked. In this polyhedron, all 6 faces are identical equilateral triangles, but it is not a regular polyhedron, because the top and bottom vertices connect 3 edges, while the middle vertices connect 4. A regular polyhedron must also be convex. If a vertex of a regular icosahedron is symmetrically inverted inward, each face remains an equilateral triangle, and each vertex still connects 5 edges, but this polyhedron is no longer convex, so we do not consider it a regular polyhedron. To summarize, a regular polyhedron must meet 4 conditions. First, each face is a regular polygon. Second, all faces are identical. Third, each vertex has the same number of edges. And fourth, it is convex. According to this definition, we can identify only 5 types of regular polyhedra. Why are there only 5 types of regular polyhedra? We can understand this by examining the construction of vertices in polyhedra. Each vertex is formed by the intersection of multiple faces. How many faces are needed to construct a vertex? This number has both a lower and an upper limit. We can keep reducing the number of faces involved in constructing a vertex until we reach 3 faces, at which point we can no longer reduce the number because 2 planes cannot form a vertex. Thus, the lower limit for the number of faces that meet at a vertex is 3. We can keep increasing the number of faces involved in constructing a vertex. During this process, the vertex becomes less sharp and more flat. Until the sum of the interior angles of all faces equals or exceeds 360 degrees. At this point, it is no longer possible to construct a vertex from these faces. Therefore, if the angle between 2 adjacent edges is theta, the upper limit for the number of faces that can meet at a vertex is 360 degrees divided by this angle. Based on this conclusion, we can enumerate the various ways to construct regular polyhedra. We will try to construct regular polyhedra using equilateral triangles, squares, pentagons, and hexagons. First, let's look at the case of equilateral triangles. The interior angle of an equilateral triangle is 60 degrees, and based on the previous conclusion, a regular polyhedron constructed from equilateral triangles can have vertices where the number of faces that meet is 3, 4, or 5. Construct 3-dimensional shapes for these 3 types of vertices. They correspond to the tetrahedron, octahedron, and icosahedron. Next, let's consider squares. The interior angle of a square is 90 degrees, and based on the previous conclusion, each vertex can only connect 3 faces. Each vertex connects 3 faces, all of which are squares, resulting in a polyhedron that is a cube. The interior angle of a pentagon is 108 degrees, which is similar to the case of the square. Each vertex can also connect only 3 faces. The resulting polyhedron is the dodecahedron. The interior angle of a hexagon is 120 degrees. The sum of 3 interior angles has reached 360 degrees, so we cannot use hexagons to construct a regular polyhedron. For polygons with more sides, the interior angles will be greater than 120 degrees, making them unable to construct regular polyhedra. Based on the analysis of various cases, we can conclude that there are only 5 types of regular polyhedra. 3 of them are constructed from equilateral triangles, while the other 2 are constructed from squares and pentagons, respectively. Over 2,000 years ago, the ancient Greeks recognized regular polyhedra and clearly understood that there are only 5 types. At the same time, they believed the world was composed of 4 elements: earth, fire, air, and water. In his dialogues, Plato associated these 4 elements with regular polyhedra. Let's explore the logic he presented. Starting with the cube, it gives a sense of stability. Multiple cubes can seamlessly fit together to form a solid structure reminiscent of the earth. Therefore, Plato first linked the cube with the element of earth. The remaining 3 elements, fire, air, and water, are all characterized by a certain fluidity. Plato analyzed these 3 elements based on 2 aspects: weight and shape. Fire rises in air, while water flows downward. Thus, fire is the lightest, water the heaviest, and air is moderate. Fire can burn and tear apart everything, making it the sharpest. Water nurtures all, thus it is the roundest, and air is moderate. Fire, air, and water are all fluid elements. Plato chose regular polyhedra made of triangular faces, namely the tetrahedron, octahedron, and icosahedron, to correspond to these 3 elements. He also assigned different properties of weight and shape to these polyhedra. Adjust the edge lengths of these 3 regular polyhedra to be the same. With equal edge lengths, the tetrahedron has the smallest volume, making it the lightest. The icosahedron has the largest volume, making it the heaviest. This way, we correlate the weight properties with the different regular polyhedra. Next, let's examine the vertex shapes of these 3 regular polyhedra. The tetrahedron's vertex consists of 3 equilateral triangles, making it the sharpest. The icosahedron's vertex is formed by 5 equilateral triangles, making it the roundest. The shape properties correspond to different regular polyhedra, and we use colors to label these attributes. Similar properties are associated with related regular polyhedra, establishing a correspondence between fire, air, water, and regular polyhedra. Finally, we have the dodecahedron. Since there are only 4 basic elements and they have all been assigned to other polyhedra, Plato's student Aristotle created a 5th element, the ether that permeates the universe, to link the dodecahedron with ether. Everything seems reasonable and gives a sense of mystery, so the association of the 5 regular polyhedra with the 5 elements has been passed down for a millennium. While this idea may not be accurate, it powerfully reflects the ancient Greeks' profound understanding of geometry and their passionate pursuit of rationality, harmony, and beauty.